So today we're working on 8B.3. Okay, we did 8B.4 yesterday, so we're going a little bit backwards because these are a little bit more difficult, so we wanted to take a block day for them. We're going to be solving systems of equations by substitution, okay? Basically, systems of equations we are trying to figure out where two lines cross, okay? That's called the solution to a systems of equations. So for a couple days, we've been working on graphing, okay? And you can graph, you don't have to draw this part. You can graph systems of equations and you can figure out where they cross, okay? That's one way to do this. But I'm going to show you another way to solve these because sometimes your graphs, they might be off the grid or the lines might be off the grid and it's difficult, okay? So this is just another way to figure out where two lines cross, okay? There's going to be 3 ways total, so we've already learned graphing. Today we're going to do something called substitution, and then we're going to do another method later next week. So sorry, I can't talk. The steps for this. For number 1, it says when solving by substitution, one equation must be solved for a single variable. Okay, so that means you have to get one letter completely by itself. This means either x or y must be on one side of the equals sign by itself. Sounds like crickets. Sorry. Okay, so single, one line or one letter must be on one side of the equal sign by itself. If your problem is not solved for a single variable, you have to rearrange your equation. Okay, so you have to move it around so that you have one letter completely by itself. Once one equation is solved for a single variable, you need to plug in the equivalent expression in for that variable in the other equation. So these are your steps. We're going to go through 4 different problems today to make sure that you kind of understand these steps. So for number 1, we have 2 different equations, y equals 6 and 2x plus y equals 12. I could graph these, okay? But if you don't have grids, it's kind of a pain to have to graph things. So what you're going to do here is we're going to you want to make sure first that one equation has one letter completely by itself. Obviously for this one, the first equation is solved for y. We know that y is equal to what? What is y equal to?
6.
6. Okay? So where we see y in the second equation, plug in 6. So literally, we're going to plug in 6 in for y. So here, 2x plus, what am I plugging in for y?
6.
6 equals 12. Then we're going to solve. So how would you solve this equation? How am I going to get x by itself?
Subtract by both sides.
Start, if you need to, you can put that wall there. So start by subtracting the 6 from both sides. That leaves you with 2x equals 12 minus 6 is 6. Then how do I get x by itself? Divide both sides by 2. And we get that x equals what?
3.
X equals 3. Now, our solution here, we already know that y was equal to what? 6. So your solution is always a point, so you need to write it in parentheses in point form. What's the x coordinate?
3.
X coordinate is 3. Y coordinate is 6. That's your answer. Okay, your answer is 3, 6. Now, you could get this way, or technically if you graphed, you could get the same answer. Okay, you would figure out that these two cross each other at 3, 6. Questions on how I did that? Not too bad, right? Okay, let's try another one. For number 2, I'm sorry, say it again.
It makes sense now.
It makes sense? Good. Okay, for example number 2, okay, here, you want to see where one equation has one letter completely by itself. So here, which equation is already solved for y? The first one or the second one?
Second.
The second equation. So the second equation is already solved for y. And what does y equal? 3 plus x. Then in x plus y, we are literally going to replace the y with 3 plus x. So in x plus y, instead of y, we're going to rewrite what?
3.
3 plus x. Then we solve. So how would I solve this equation? What do you have to do? Combine the like terms. Okay, so what's x plus x?
2x.
2x plus 3 equals 5. Then how do I solve? You can put the line if you need to.
Subtract 3 from both sides.
Subtract the 3 from both sides, exactly. That leaves you with what?
2x equals 2.
2x equals 2. And how do I get x by itself?
Divide 2 from both sides.
Divide both sides by 2. So you should get that x equals what?
1.
X equals 1. So in our equation, okay, in our solution, you're going to have to put x comma y. I have the x part of 1 already. Do I know what y is equal to?
Yes. 3.
Do I know what it is yet?
No.
No. But I can take x equals 1 and I can plug it in to one of the equations up here. And you can solve for y. So y would equal 3 plus, what did you say your x is?
1.
1. So y equals what?
4.
3 plus 1 is 4.
4.
So y equals 4.
4.
That is your solution. 1 comma 4. So you solve for one variable or one letter, plug in to solve for the other letter. Yes. It does matter because remember when we're writing a point you have to write x then y. So x comma y. So if you wrote 4 1 that is absolutely wrong. You have to write x comma y. It's just like when you're writing a coordinate. Questions so far?
No.
Okay, let's keep going. Look on the back. Next page. For number 3, excuse me, x equals 3 minus y and x plus y equals 7. Here, which equation is already solved for x? The first one or the second one? The first equation is already solved for x. And what does x equal?
3.
What does x equal?
3.
3 minus y.
Oh.
Not just 3, but 3 minus y. So here, you're going to plug in 3 minus y in for x in the other equation. So instead of x, we're going to rewrite this as 3 minus y plus y equals 7. What happens here? When I drop those parentheses, we get 3 minus y plus y equals 7. If you combine like terms, what happens?
2y.
We get 3. What's negative y plus y?
2y. 1.
Okay, negative 1 plus 1. 0.
0.
They cancel each other out. So we get 3 equals 7. Does 3 equal 7?
No.
No. So if you get a false equation, okay? So because this is false, what do you think that means?
Incorrect. Not right.
Okay, but what does it mean? Remember we were talking about graphs. What do you think that means? No solution. Exactly. They're never going to cross. These would be parallel. So this system has no solution. Okay, no solution. When we're talking about systems of equations, if you're talking about straight lines, there's 3 different options. They could cross one place. Can 2 straight lines ever cross 2 places?
No.
No. 2 absolute straight lines cannot cross in 2 places. Okay? You have 3 different options here. Nope. They can either cross in one place, in which case you'd have one solution. They could never cross. How would you know if they never cross? They'd have to be what? Parallel. Or they could always cross. They could be the exact same line, and what's that called? Infinite solutions. Okay, so 3 different options. So this means no solution. For example, number 4. Here, do I have any equation that just has one variable or one letter completely by itself?
No.
No. Which one do you think would be easiest to solve for?
The first one.
It's easiest to solve for which letter?
Y.
Solve for y, or excuse me, solve the second equation. Sorry, that should be second. It's easiest to solve the second equation for y. So how would I get y completely by itself in this equation? What do you have to do? Subtract the 2x. I'm sorry. I did mean the first. Thank you, Sarah. I'm sorry. First equation. I'm sorry. It's easiest to solve the first equation for y. Thank you. Next. Thank you. First equation for y.
She said no.
I'm sorry. So y equals negative 2x plus 4. So here we got y is equal to negative 2x plus 4. Now we're going to take this y equals negative 2x plus 4 and you're going to plug it in to the other equation for y. Okay, so we're going to plug this in for y. So 4x plus 2 times, I'm going to substitute negative 2x plus 4 is equal to 8. So I took this equation and we're plugging it in right here. Now you have to distribute, so we're going to multiply through. If you distribute, we got 4x. What's 2 times negative 2x?
Negative.
Minus 4x. 2 times 4 is plus 8 equals 8. If I combine like terms, what's 4x minus 4x?
0.
Where did I lose you guys?
0.
Oh.
What?
JK.
Okay, so distribute. Is that where I lost you?
What?
Okay, hold on. Now, 4x minus 4x is what?
0.
0. These go away. So I'm left with just 8 equals 8. Does 8 equal 8?
Yes.
No.
Yes. Okay. Yes, 8 equals 8.
No.
So because this is true, listen,
Right.
because this is true, this system has what?
One solution.
Nope.
Infinite.
Infinite solutions. Okay, infinite solutions. So basically, these are the exact same line. Okay, these would be the exact same line. So if you get a true equation, if all the letters cancel out and you get two numbers that are equal to each other, that means infinite solutions. Listen, if all the letters cancel out and you get a false equation, so one number that doesn't equal a number, so like 0 equals 4 or 3 equals 7, that means no solution. You know you have one solution if you get an answer for x and y. And most of the time, you're going to get one solution. You're going to get one answer for x, one answer for y. Okay? These are kind of the special circumstances, but I promise you on your test, you're going to have some that have special circumstances. Okay? And probably on your state test as well. Do we have questions on how I did these? Pretty good for now? Okay.